Okay, so welcome back. We are in a new chapter and it's unit 7 and it's called Trig functions, equations, and identities. We've already dealt with functions, so we're just going to go a little bit into that and make sure that you remember what to do. And then we're also going to deal with one more letter that will control the function in a specific way. So technically, I'm going to say there's nothing new that I'm teaching you today. So today you'll be able to shift the graphs of trig functions horizontally. So that means left and right. So if you remember all the functions that we dealt with before, there was a place where you would put a number in that function that would be responsible for shifting a graph horizontally. Okay. So how can I represent the horizontal and vertical motion of a rider on a Ferris wheel if her starting position varies? When should I use a sine equation and when should I use a cosine equation, or does it even matter? So in this task, we revisit the amusement park Ferris wheel that that caused Carlos so much anxiety. Recall the following facts from the previous task. The Ferris wheel has a radius of 25 feet. The center of the Ferris wheel is 30 feet above the ground, and the Ferris wheel makes one complete rotation counterclockwise every 20 seconds. So the amusement park Ferris wheel is located next to a high-rise office complex. At sunset, the moving carts cast a shadow on the exterior wall of the high-rise building. As the Ferris wheel turns, you can watch the shadow of the rider rise and fall along the surface of the building. In fact, you know an equation that would describe the motion of the sunset shadow. So if you're confused at all, just can you, oops, I don't need the decimals right now. So if you're confused, just think about like here's the Ferris wheel, right? And then so don't look at all of the riders, just look at one particular rider. And then because it's sunset, maybe the sun, I don't know, whatever is right here, and it's going this way, it's casting a shadow against this building. So it's at sunset, and you guys are like, man, Miss Johnson, that sun is really, really close. Just ignore how close I've drawn it and just pretend, okay? So it's going to cast a shadow where this shadow goes here, and then as the rider goes, around this thing, then it goes down here, down here, down here, down here, all the way to the bottom. And then it goes all the way up again, right? Same shadow. So it's just the shadow's traveling up and down. That's all it's doing. Okay. As time goes on, the shadow is going up and down. So they want you to write the equation of this sunset shadow. Sunset shadow. Okay. So go ahead and take some time and think about like, okay, how would I do that? And then what does that look like? Kind of thing. Okay. So the way that I would figure this out is, let's see, hold on a second. So if like, it makes sense to think that because we're looking at this shadow, the shadow is going up and down. So when you think of up and down, who do you think of? Sine or cosine? And hopefully you said cosine. I mean, sorry. Hopefully you said sine, because sine is more closer, if you've been paying attention to our things, it's more closer to our y variable, right, of moving up and down. So here we are going to write the equation y is equal to, and then we're going to write a sine equation. If you remember what number goes here, it's the amplitude number. So it's how high above and below it goes, right? So this is going to be 25 because that's the radius of our Ferris wheel. And then we have sine, And then we also have our plus 30, because that's how high the center is off of the ground, right? And then if you also remember, it takes 20 seconds to go all the way around the circle. So then we go like this. We go 360 divided by 20 is equal to 18. And this is our angular speed, right? It's degrees per second. And so this 18 goes right there. I think that was a confusing part for you guys the last time. And so I'm going to put a T there. And that's our equation, right? So similarly, it says at noon, when the sun is directly overhead, a rider casts a shadow that moves left and right along the ground of the Ferris wheel. And then this is how, remember, this is when you would draw the cosine of this. So it's going to look exactly the same. Y equals 25 cosine 18t plus 0, because there was no, it was on the ground, right? So there was no up and down. Okay, so you guys, this is old stuff. This is not anything new. I just wanted to make sure that you guys remember this. Okay, so based on your previous work, you probably wrote these equations in terms of the angle of rotation being measured in degrees. Revise your equation so that the angle of rotation is measured in radians. And so, so now what we're doing, so if you remember, and this is what we did here, we did 18 degrees per second, but now we want to consider this in terms of 2 pi. So now I'm going to do the same equations except for go 2 pi divided by 20, which would be, and I'd simplify this, and then so that would be 10. So this would be pi over 10 radians per second. So what does that mean? It means that's how fast that's how fast the shadow is traveling left and right or up and down on the building or on the floor. It's traveling pi over 10 radians per second. So then I'm going to change out my equations, the same equations that I just drew here. So now I'm going to go with y equals 25 sine pi over 10 t plus 30, and y equals to 25 cosine pi over 10. I should put this in parentheses. T plus 0, right? So this is not anything new. We haven't done anything new, okay? So this one says, oh, I wrote those down because it says write each of the equations, so I did that. It says in the equations you wrote in problem 3, where on the Ferris wheel was a rider located at time 0? We will refer to this position as the initial position 0. So if you remember, he was at position A. Remember, that's what we called it. But now we know he was at like 0 degrees or 0 radians. So now we're just going to be calling this 0, right? So this was A, if you remember A, it was the rightmost point. Or if you want to call it, it's 0. That's our starting point, right? So now it says revise your equation. Hold on a second. It says revise your equation so that the rider's initial position at t equals 0 is at the top of the wheel. So they want us to go back to problem 3. So that's these two equations here, right? But now instead of it being at 0, t equals 0 is there. How does that look when we when it moves, when they start at pi over 2, which is at the top? Like if you remember this guy up here, his name is pi over 2, right? So this is basically, because we're going to start here, I want you to think about, okay, well, how does this fit into our equation? Where would you put that? Where would you put that? So go ahead and pause and think about where you would put in this pi over 2. Okay, now that you're back, so I want you to think about like, so remember Carlos was here and then it takes him so long to get over here, right? It takes him so long. And so whenever we're talking about time, it's going to affect this guy. It's going to affect your x direction and not your y. Your y is affecting how high or how low he goes. So if you think about like how we're comparing this function here to now having them have the start position up here, right? This guy is pi over 2 ahead of him. It's pi over 2 ahead. So that means I'm going to add pi over 2 to these functions. Where does that go? Okay, so now instead of my equations being, I'm just going to write my equations. So instead of, let's see, the sunset shadow. So this is going to be y equals to 25, still the same, sine of something. Now I'm going to keep all of this kind of the same, plus 30, right? So the 25 didn't change, like how high and how low he goes doesn't change. The fact that the center of the wheel doesn't change. The only thing that changed is your start position. So our start position before was pi over 10 times t, right? But now we don't have him starting at the rightmost point. We have him starting at the topmost point. So now if you think about that, I need to add pi over 2 to that. So this is the reason why we have this pi over 2 is because that's where the writer is when he is at pi over 2. So it's very familiar to us, okay? So same thing goes for the other guy. It's going to be y equals to 25 cosine, still pi over 10, still times t, still pi over 2, plus 30. So nothing really changes except for that pi over 2. Oops, not plus 30, sorry. I was thinking I was in the other equation. Okay. So Ms. Johnson again, why are we moving at pi? Why did we have to shift it pi over 2 in the x direction? Because now let's see, explain this. So now instead of your starting point, him being here at point A, he's up here. And so we figured out that this right here is pi over 2. That's pi over 2 in terms of the circle, in terms of that angle. Does that make sense? Okay. So let's continue. So now they say, okay, revise your equation again so that the writer's initial position at t equals 0 is at the bottom of the wheel. Wait, bottom of the wheel. So please remember that the bottom of the wheel is this guy right here. Now, what angle is this guy right here? What angle is that? And hopefully you guys said 3 pi over 2 because then you're right. So now what am I going to do with my 3 pi over 2? What am I going to do with my 3 pi over 2? And some of you are like, oh, Ms. Johnson, just add it. Instead of you adding pi over 2 like you did before, add 3 pi over 2. So exactly. So I get y equals to, Ms. Johnson, nothing happens to the 25? No. Nothing happens to sine? No. Pi over 10, Ms. Johnson, does anything happen there? No. The only thing that changes is this 3 pi over 2. Ms. Johnson, is it because now you're saying that the starting point is at 3 pi over 2? And I'm like, yeah. Right? So can you just imagine yourself on the Ferris wheel? I don't know if you've ever been on a Ferris wheel. The very first thing that happens is they have to load the Ferris wheel. And so, like, let's say you're the second car that means you have all of these, you have to go all the way around the wheel. So let's pretend that you're this, that this is you right here. You get on, they load you on, and then they load on, they have you, they rotate the wheel and then they pause the wheel, right? And then they're pausing the wheel because they have to load another cart full of people on it, right? And then you go some more and then you pause again, because then now they're doing it more. Now, the reason why I want you to think about the start position is, when do you actually start the ride? You don't actually start the ride here when you get on. You actually start the ride when the Ferris wheel is going all the way around over and over again, right? When you're actually continuously going. So that's what I want you to think. Like, when did Carlos actually start the ride? Did he start it at the top of the wheel? Did he start when he was at the rightmost? And that's going to help you understand what this, kind of function is. So similarly, you're going to go y is equal to 25 cosine pi over 10 t plus 3 pi over 2, so that you guys can do that, right? All right, so I'm going to have you guys do this one. It says, revise your equation again so that the writer's initial position is at the leftmost point. Let me show you where the leftmost point is. The leftmost point is here. What is that called? Can you write me an equation that would describe that? Can you write me an equation that would describe that? Okay. So now that you're back, here's your equation. So I still get y equals to 25 sine. I still get pi over 10 t plus something plus 30. And this time I'm going to add pi to it. Okay. And then the same thing goes to the other one. And then the reason why this makes sense to you is because you're like, oh, instead of us starting at 0, that's the position that he was at before, when we kept talking about the rightmost point, the rightmost point, the rightmost point, that's the 0 point. Now we're having them start in different positions, namely in this one at pi. Okay. All right, we're going to revise the equation again. It says this time it's halfway between the furthest point on the right and the top of the wheel. What? So let's draw a picture of this. So here's the rightmost point. Here's the top point. It says, so it's halfway between the furthest point to the right and the top. Oh, so halfway. So that would look like something like this. So your brain should instantly jump in order and say like, oh, what angle is that? What angle is that? Now, some of you can figure this out just by these 3 dots alone. Some of you are trying to figure out how many slices of pie there are. That's really good. Whichever way you get, make sure that it makes sense to you. Okay, so here's a couple ways. So if this is 0 and this is pi over 2, what's halfway between pi and pi over 2? And some of you are like, oh, it's pi over 4, Miss Johnson. Exactly. Other people figured out that, okay, like I need a halfway point here. And then, oh, that's pi over 4 because there's 4 slices of pie between 0 and pi. Some of you thought about it in terms of 2 pi, and you said 2 pi divided by 8. Oh, that's pi over 4. However you thought about it, great, do that way. So how does this now affect the equation? Go ahead and write out your whole equation. Okay, so now I'm going to write the equation. It's y equals to 25 sine of pi over 10 t plus pi over 4 plus 30. And then y equals to 25 cosine of pi over 10 t plus pi over 4, right? Very good. So see if these things are making sense, and you could basically summarize all of this by this. This number here, the new guy on the block, right? His job is to tell me where I start. His job is to tell me where I started on the Ferris wheel. Okay. So it says revise your equations from problem 3 so that the wheel rotates twice as fast. Okay, so twice as fast has to do with some of that initial information that they gave us. So I'm scrolling all the way back up. Hopefully you're not getting dizzy. So before, if you notice, it went in one rotation in 20 seconds. Now, when something's going twice as fast, how big the Ferris wheel is, meaning the radius, isn't affected, and how high it is off the ground is again not affected. But the 20 seconds is. Now read it again. It says that what happens when the wheel goes twice as fast. So before, if it completes one rotation in 20 seconds, what is the speed now? Is it going to be one rotation in 40 seconds? And you're like, no, because that's slower. Oh, okay. So what would it be then? In how many seconds? You're right. It's going to be in 10 seconds. So before we did 2 pi over 20. So now I'm going to do 2 pi over 10. Wait, what did I do? Sorry. What am I doing? Sorry. I lost my little thought there. Oh, yeah. That's right. I'm going to do 2 pi over 10. And then when I simplify this, this will just be pi over 5. So what number am I now affecting? Right? So now they just want me to go, and then so go with the original question. So this is going to be y equals 25 sine of pi over 5t plus 30. And then y equals 25 cosine of pi over 5t. Right? Ms. Johnson, where'd you get pi over 5 again? Well, because over here, when we did it before, you just take your 2 pi and you divide it by how long it takes you to complete one revolution. And so this would be pi, and then now it doesn't take us 20 seconds anymore. It takes us 10 seconds because we're going twice as fast. So then we get pi over 5, and this is pi over 5 radians per second. So can you just imagine, like, that's how fast it's going around. That's how much it's covering in a second. Okay. So now revise your equation from problem 3 so that the radius of the wheel is going twice. Revise your equation so that from problem 3, so your original equation, so that the radius of the wheel is twice as large and the center is twice as high. Right? So if you remember, twice as large, before the radius was 25, now it's going to be, our new radius is going to be 50. And if it's twice as high, before that we called it D. D was 30, but now it's twice as high, so now D equals to 60. Right? So then we're going to write that original equation. So that's going to be y equals to not 25, but 50 sine of pi over 10 t plus 60. And same with y equals cosine, 50 cosine pi over 10 t. Right? So there's your equations. I think I moved on that one too quickly. Okay, so now it says Carlos wrote his sunset equation for the height of the rider in problem 5 is this. Okay, so problem 5. What was problem 5? Problem 5, sorry for making you dizzy. Oh, when the rider is at the top of the hill. Okay, so look at your equation, what we wrote together. So now we have, then he write this. He wrote 50 sine pi over 10t plus pi over 2 plus 30. So I'm going to do myself a favor. I'm going to just copy our original equations to down there so that we can compare them. Give me a second. Let me just do it on the computer because it's faster. Okay, so from problem 5, let me just go here and put it on problem 11. So here's our original equations, right? And I'll put them out a little bit. Okay. There they are right there. Can you compare your equation to Carlos's? Okay. Are both of these equations equivalent? 50 sine pi over 10t plus pi over 2, we got that, plus 30. Are those going to be the same? Are these two equations the same? 50 sine pi over 10t plus pi over 2 plus 30. Is it the same as this one? So some of you are seeing, Ms. Johnson, I see the 50 is changed. I see this pi over 10t plus pi over 2 is the same, and I get the plus 30. Hold on a second. So are these two the same? And then, so what do you think? Are these two the same? 50 sine versus 25 sine. Pi over 10t is the same as pi over 10t plus pi over 2 plus 30 is the same. Okay, and so let's look. So let's write an equation. It's 50 sine pi over 10 t, I'm going to use x instead, plus pi over 2, and then plus 30. Okay, and so you're like, oh, I see that equation. Ooh, there's my equation. Looks kind of crazy. And then you want to write this one. And then you want to write this one, and it says my sunset equation. Oh, where's mine? Where's my equation? Oh, there it is. 25 sine. And I just realized I would have just copied. That's okay. So pi over 10t plus pi over 2 plus 30. Okay. Oh, I'm sorry. They're comparing Carlos's and Clarita's, not Carlos's and ours. Okay, sorry. So here's Carlos's, and here's Clarita's. So we get 50 sine pi over 10 t plus 5. Oh, they put a t plus 5 here. So the only thing that I see different between these two is just this inside stuff here and this inside stuff. So when I see that, I just want to kind of distribute and see what happens. So what's pi over 10 times t? And you're like, oh, it's pi over 10 t. And what's pi over 10 times 5? And you're like, oh, I can simplify those by 5. And so then this becomes a 2. And you're like, oh, Ms. Johnson, those are exactly the same. You're like, oh, that's weird. How can they be both the same? So let me plug this in here. 50 sine of pi over 10, and then parentheses x plus 5 plus 30. I don't know if you noticed, but they're the exact same. So I'm going to take off green. And red and green are exactly the same. And now you know why graphically, and now you can be sure of that algebraically. It's because pi over 10, if you distribute it, it's the same thing. So whenever I see these things and they're equivalent and they look different, but their value is the same, I want you to think of this is a $20 bill and this is two $10 bills, right? So Carlos says his equation represents starting the rider at an initial position at the top of the wheel, right? Because there's that pi over 2. What does Clarita's represent? What does Clarita's represent? So it's not going to represent the position. So here's the speed. Remember that this is how fast the wheel is traveling, pi over 10 radians per second. And then here's your seconds. So this must be seconds. So this is a 5 as in 5 seconds. So Clarita's equation represents the same thing as Carlos's, except for Carlos represents the position that they're at versus Clarita is the amount of time it would have taken, the like almost like a head start. So 5 seconds after the rider passes the 0 point. Does that make sense? So they're both starting here at the very top of the wheel, if that makes sense. All right. So we're pretty much done. So here's what I want you to do. I want us to talk about all of the letters that that we discussed so far in terms of graphing it, just so that we're all on the same page. So there's two different forms that when we talk about a phase shift. So phase shift, the reason why they're talking about it called a phase, because the phase shift is shifting that whole cycle. Like, remember how it just repeats? It'll repeat right here, and we're just gonna pick it up. It's almost like I'll just go like this, like right. And so let's say that I did a better job of that, and I shifted it, right? So I want you to pretend that the phase shift goes like this, right? So if it was normal, it'd be here, right? But there's phase shifts that move it forward or backwards, giving someone kind of like a head start or I don't know what it's called, like behind the fact, right? So that's all I wanted to talk about with that. But here's your two forms. The first form that we looked at was like y, oops, let me get a color. So we get y equals to a sine of bt plus c plus d. And the other form was y equals to a sine, notice these are the same, plus d. The a and the d are still exactly the same, right? Except for this time we have this like distribution inside here. So this would look like this. Don't worry about that C over B business. It's just different. So it just depends on what you want it to talk about. So form 2 reveals, this form 2 reveals the magnitude and the phase shift. So how much I need to scoot it over. Okay. In terms of the circular motion of the wheel, form 1 is easier if we focus on a shift in the starting position of the Ferris wheel. So it's better. It's easy for form 1. It's easier easier to write if we focus on the starting position. Like, where did he start? Oops, position. I don't know how to spell, guys. Right? But form 2 is easier if we're talking about the timing of the writer. relative to when they pass the zero. Does that make sense? So here we're talking about starting position versus here we're talking about the timing of when the writer passed the A or zero position. Right most point. Okay. So that's pretty much it. The biggest thing that you were supposed to learn here is number one, there's two forms. This is basically form 1 and form 2. Form 2, this one, is talking about the initial position of the writer. So that's your initial position, right? Versus this guy over here, this is talking about how long since the writer passed zero, meaning the A spot, right? Okay. The other thing that you were supposed to be comfortable with is it doesn't matter in terms of like sine or cosine. The job of that, say 25 or 50 is still the same. Okay. So now you should be able to do your exit ticket, your ready, set, go. You should be fine. If this is feeling a little bit uncomfortable, it should, because this is the first time that we've ever talked about phase shift. And again, phase shift is just how much it's scooting over. That's all. Okay. I hope you have a great day. Thanks for listening. Bye.